First of all, everybody, thank you for coming to the spa day. We completely scammed you. There is no actual spa happening here. It's single-page apps. Sorry. No cucumbers, nothing. But it's kind of play on words, but single-page applications are the thing that everyone is focusing on the front end these days. Chariot has been doing consulting in AngularJS and then Angular and now React as well for a while now. And so we figured, as part of our giving back to the community, we would do a day like this to kind of share what we've learned, talk about the similarities and differences across the different platforms, talk about some different, concepts for things like design and running servers. So hopefully this day is, if you're just trying to get a feel for what the different frameworks and platforms look like, this will give you a little bit of a taste. We also are going to have the presentations on PDF available, I would say today, but I have to upload them and we have to do a little more tweaking. So sometime this week or early next, worst case, and we'll send out an email to everybody. And all the sample code will be available as well on GitHub. So you'll be able to take a look at that, kick the tires, try things out, make it better than what we did when we were trying to hack it together. So thank you for coming. I appreciate it. Just a quick, before we start, show of hands. How many people today are doing a single-page app? Okay, a fair number of you. How many of you are doing it in AngularJS? A couple of you. How about in Angular? Ooh, the enterprise is here. How about in React? Oh, the hippies are here. All right, wait. How about in Vue? Right. Everyone's like, I think maybe at some point I'll be doing Vue. That's what I'm talking about. So that's exactly where I thought we were going to be. There's like some people that are still on AngularJS, probably because you started on AngularJS, or it was stable at the time, or you looked at Angular and went, these people are crazy. Then there are the enterprise people that once it actually got released, they're on Angular, and a lot of enterprise developers, it's a nice selection. And then there are those thinking about, there are people doing React now, and that's starting to grow in numbers, and that's what we're seeing as well. So it looks like we're in good company. If you work with Angular, you're going to learn a lot about the other two, and vice versa. If you work with React, you'll learn a lot about Angular and Vue. All right, so I'm Ken Rimple. I do our training for Chariot Solutions and mentoring. So I have training courses in React and Angular. Before that, I taught AngularJS for about 4 years that I wrote myself. We actually, Andrea, who's in the audience with me, helped me write the Angular and the React training. Before that, I used to teach things like Spring and Maven and stuff like that. I was an enterprise app developer before I got sucked into the vortex of JavaScript. So we're going to talk about single-page applications. And this opener is just to kind of make sure we're all kind of talking the same language. I'm going to kind of gauge through the room and see if I'm talking about a topic that everyone's like, if you start doing that a lot, I'll move on. But I just want to kind of level set it because all of our code is going to look somewhat similar in a way because we're using ECMAScript 2015 and things like that. So, all right. So what is a single-page application? It's just a client-server application. Technically, it's a 3-tier client-server application, and I didn't show the database. But on the left, we have our app. It's in JavaScript. It's running in the browser. And in memory, JavaScript is in control. You're not navigating to a whole new page every time you click a menu link. You're just replacing some part of the page, and it looks like you're navigating. They call that magic routing. Right? Just like there's routing on servers, now there's routing on clients. So we're just flipping what div or section we're showing based on a navigational metaphor, like a button or a menu link. So that's one of the things it does. It's got a nice rich user interface. It feels more like a desktop app. Has client-side logic. It can cache things, like cache your security token and things like that. And it makes requests to the server. Primarily, you cannot read that word. It's HTTPS traffic, but it's HTTPS or network traffic. And all we're doing is we're saying, do a get, post, put, delete, or patch call, which are the different verbs you can do against the server, with some URL that makes sense to the server, and it spits back some sort of data output. The fancy name for that is REST, representational state transfer, because the state is sitting behind the server somewhere. The client says, give me the data for my list of customers and give it to me in JavaScript JSON format, and that's the representation, and the state transfers give it to the client. Beyond that, everything else about REST is a big giant holy war that everyone disagrees with. How do you put your verbs and nouns together? We're not going to get into that today because that could be a whole debate. But we're going to use some real basic URLs that fetch and create registrations for spa sessions as our sample application. And in the second talk today, Pete is going to be talking about the actual user interface itself. On the server side, our server used to be really heavyweight. It used to have to spit out HTML pages and hold on to state. And so you would have sessions and worry about, sticky sessions and clustering and things like that. All the expensive stuff that happens when you have servers that have to keep some sort of server side information. Well, now when you do a single page app, some of that stuff can stay in the client and stick around. And so you don't necessarily have to cache on the server if you don't want to. You don't have to hold on to much, if anything, on the server, depending on what your app does. Maybe your security is completely handled by one little module that gives you a token, right? So that's something that isn't as complex and as heavyweight as it used to be with a regular server-side, JSP or .NET app. And so they're generally mostly stateless now, and they handle the business logic and the security. We're going to look at 3 platforms, as I mentioned: Angular, React, and Vue. So I'll leave those for the talks they're going to be in. But why a single page app? So first of all, you've got this rich front-end experience. You've got a nice, snappy response to things. It feels like a desktop application. You have no full page refreshes. Whenever you're on a website now that does full page refresh, you must be thinking you're browsing a news site, right? Oh, I'm on the New York Times, click. And even those are getting more, up to date. But, oh, great, I've clicked the link, now I gotta wait for the whole page to load. It feels like an eternity. So a single page app should feel snappy, give you indications that something's happening when it's doing something on the server and so on. Just like a mobile app would. So you'll have things like spinners and things like that. And it's truly a full client. You've got the browser, but it's sitting on a computer with probably 4 to 6 to 8 cores. Use those cores, right? So the goal would be write applications that can take advantage of the computers they're running on if possible. And again, reducing your server complexity and having a true conversation. The idea is you'll load the page content here and there as these templates or things you render, but most of your conversation back and forth is going to be, requests for data, updating data, that kind of thing. Like a real client-server application, because it is. So what I thought we'd do first is talk about some of the skills you need in order to be, good at single-page app development. And just bear with me one second while I bring my notes up. I'll move these out of the way. I forgot to do that. There we go. All right, so mad skills, right? We got to learn, make sure we're okay with the technology terms that we're going to be looking at today. If you're not sure what we're talking about in these, then there's your research. Okay, so if you feel shaky on things like promises or anything we're talking about or observables, and you happen to be working in some of these technologies, those are the areas you need to research. But first of all, let's talk about what modern JavaScript is. You'll hear the term modern JavaScript or current JavaScript. So JavaScript itself has been a moving target since 2015, let's call it. JavaScript had changed in 2009. There was this version of JavaScript called ECMAScript 5. By the way, ECMAScript is the technical term for JavaScript. When they created JavaScript, it was a copyrighted name, it's Sun, so they said, we can't call it that. So the official name is ECMAScript. And so that's when you hear ECMAScript, it's just JavaScript, it's the official name. And so JavaScript, technically there's like a 2007, 2008, 2017, 2018, 2019 versions of JavaScript. They're just things that made it into the spec that year. So all of that started in 2015. So we went from 2009. In 2009, there was ECMAScript 5, and it stayed like that because of a raging debate over what to do with the language for a long time. 6 years, I guess. And so they finally came up with what they wanted the most modern version of JavaScript to have. All the things that all the other programming languages have. Local variables, right? Instead of just function scoped variables. Arrow functions, which are like lambdas in other programming languages. That all made it in. But they said from that point forward, we're going to have yearly releases of the language. And at the same time, all the browser developers, browser manufacturers were creating evergreen browsers like Edge and Firefox and Chrome all update themselves now. So at least in a consumer setting, you're usually working with the most recent version or close to recent version of the browser. So they figured they would hook onto that cycle between the two groups and make sure browsers keep updating for better standards. So it's a lot different than it was in 2009, where we had to wait a long time to get an update from a browser vendor. Now, realistically, what we do as developers, we can't trust this. We might want to work on the most recent version of JavaScript, but we can't. And the reason we can't is because not every single browser you're going to use in the enterprise specifically is going to actually run ECMAScript 2015 or whatever version you think you're going to write the code for. It might not have all those nice doodads on it, so you might not have, the ability to run promises almost like the regular code, which we're going to see. So we transpile through something called Babel. And Babel is just going to translate it down to an older version of JavaScript so everything can run it. So that's what everyone's doing now. If you are developing in React, if you're developing in Angular, if you're developing in Vue, you're probably running a development environment that has something called Webpack. And Webpack does all the work of, when I hit save, there's a development version of it that says, yep, you saved. I'm going to translate all your modern code down to ECMAScript 5. And that's what we're all doing at the moment. So ECMAScript is JavaScript, so let's just get over that. And also ES is another shorthand for the same thing. So let's just get that term out of the way. And this is Babel. So Babel is our build tool that transpiles. Now, who here is experimenting with or using TypeScript? Okay, half of you. A lot of you are probably doing Angular or React. So with TypeScript, TypeScript is its own compiler, and it does the same kinds of things, but it's kind of like adding types and other special features to JavaScript. And it's doing the same thing. It's transpiling it down to ECMAScript 5, to an older version of the language so you can run it. Okay. Now you can also target a newer version of the language. So you could say, you know what? Now that my browsers are all getting up to snuff and they're up to ECMAScript 2015, I'm going to target ECMAScript 2015. And so you can change these compilers to say, now I'm targeting a slightly newer version. And you do that because some of the versions of the software, what they have to do is not only do they have to give you this old syntax, but they have to run things, browser shims or things like that have to make it look like you've got the features of a modern browser. But they're emulating them in software that's written in plain old JavaScript. Promises, for example. They're called polyfills. You load the script and it says, oh, you don't have promise in window. I'm going to add that for you. So it adds a JavaScript version of the promise spec written in regular JavaScript, which is probably slightly slower than the version written in C, which is what actually happens inside of the JavaScript runtime. So if you can target a more modern browser, it could be a little faster to run a feature as that feature becomes part of the actual code of the JavaScript runtime. And we're getting to the point now where almost every evergreen browser is at least at ECMAScript 2015. So I think in the near future, people are going to be more switching to that than staying with ECMAScript 5. Now, from a design perspective, someone on your team, and I'm not going to say, there's the whole thing about full stack developer. No one is an expert in everything. There's no way to be. You can just get better at different things over time. But if you've got a team of developers working on your front end, someone better be decent at dealing with CSS and HTML. And over time, you should get good at that as well if you're a front-end developer, because a lot of what you do is interact with the DOM and change things and turn on classes and turn off classes, make things visible, animate them. That's going to involve learning some of those APIs. So that's important. We'll talk about cascading style sheets a little bit. I'll go back to that. So cascading style sheets are the thing that implement the design, right? We've all used these probably in different HTML apps. Each of these frameworks has a different way, a different take on integrating, and maybe some multiple ways, in integrating styles with your application. So Angular has a particular way they like to do it. There's a bunch of options for React. Vue has a way they'd like to do it. And we'll show you how that works in each of these platforms. From a JavaScript perspective, at this point, I don't think you're going to be doing much jQuery anymore. It was really useful a decade ago, but now one of the reasons it was there was because browsers were completely incompatible in a lot of ways. A lot of the DOM APIs were not quite compatible, let's say, at all. The CSS stylings are completely different. So if you wanted to bring something to the front or hide it or do something with it, you might have like the variant for Safari to make it work, or the variant for Firefox to make it work that might be a little different. Anyone ever did a Mozilla style before? Something like that, like in special style sheet styles that only one browser uses? So jQuery did a lot of that logic and said, oh, if you're on this, we'll do this for you. We're just going to call the thing, rounded corner or whatever. So now that's not necessarily needed anymore, and we're all using mostly regular JavaScript. There's actually a website out there called You Don't Need jQuery, because the DOM has gotten so good you don't really need to use it anymore. And I know this is obvious for probably everyone in the room because we just did the show of hands, but everyone hopefully knows that JavaScript isn't Java. But when you start with JavaScript, if you're brand new to it, you might think it is. So certain things will hurt you, like the this keyword. Who loves the this keyword in JavaScript? Loves? Yeah, everyone put their hand down. Well, if you understand it, you'd love it, maybe. But it's different, right? So a lot of people struggle with that. So there's that put a Java developer in a JavaScript platform mode and their minds melt for about 4 weeks. That's normal. But then you'll start thinking more in a functional language that has objects as opposed to a class-based inherited language. And we'll talk a little bit about that. The other thing is, as you start doing development in these platforms, you get really careful about the event loop. Who here has had a problem with the event loop was tied up by like a keystroke and locked up the whole browser? Anyone do that before? Or something like a mouse drag. I had a customer that actually was trying to figure out a problem with an AngularJS app. They were resizing widgets. And they had some math to calculate the width and the height and the depth. And they put it on mouse move. So you do 500 mouse moves in a drag of the mouse, and it just completely flooded it, and that was it. So you do care about things like the event loop. This is in some ways, if you've ever done swing programming back in the 90s or early 00s, or anything like UI, dependent on MFC, there was the event loop, same thing here. NodeJS, same thing. You've got this loop that says, I'm ready for more work, Mr. DeMille, and Mr. DeMille says, here you go, here's more work, and we just keep going through and doing it. The faster you can clear that event loop, the quicker your UI will be. All right, brief JavaScript skill dive, just so we're okay with all the terms. All right, because this is the JavaScript single-page app day. So first of all, JavaScript does not have classes for reals. It's not really classes. They're constructor functions. And what's more, they don't have true parent classes. Since there are no classes, we have this thing called a prototype. So forget everything you know about Java, because it doesn't matter. They gave these nice little things like this a very similar name because they said at the time of creating it, you're going to be Java's little buddy because Java, applets are the future. Yeah, that didn't happen. But that's why it is what it is. They created it to look a little bit like Java. But let's talk about what happens when you create an object. So you can create an object a bunch of different ways, but one way to create an object is to call this function called object.create. An object creates a new object, and it lets you pass in something called a prototype. Now, there are other ways to do this, but this is kind of showing you the direct thing that is actually happening under the covers. When you create an object, like obj here, and you create it and point to a prototype object, what happens is it now will search that prototype if it doesn't find a method or property you have in your object. So I create obj, great name. I add a property called name to it. Ken, whoever he is. And then I say console.log object.say hello. Obj does not have say hello, but the prototype does. So it searches upward and it says, okay, what's the prototype of obj? Well, I just told you. It's prototype. Why, thank you. So it says, fine, prototype has to say hello. And the other thing you remember is the prototype operates on the current instance of data. See the this in there? We're not in Java. This isn't like ancestor class and this is different. No, we're in prototypical inheritanceville. So that means that this prototype function runs against obj directly. And so the this is obj. If you get that, you get the basis of JavaScript, most of it. So prototypes, that's all we really have. All the other stuff you do, for example, this, you're not building a class. It might call it a class, but when you console dir it or something and you look at what it is, it's a function. So this example is what we can do in ECMAScript 2015 and higher. We can say, and even in the browser, you can open a console in any modern browser and create a class. When you're done creating the class, you run it as a function. It's a constructor function. So this class is a class called person, a function called person, and the function called person has a constructor in it. That'll ultimately be the function that it turns into. It's just a nice name for it. Constructor. Oh, I feel like I'm in an object system. Thank you. And I can give it my parameters, and I can say this dot something equals the parameter, and I assign the value to the instance of the class, I think. I'm actually assigning it to an object. That's all I'm doing. So when I call new on person, because there's a new, because we're Java's little buddy, but we're not Java, it runs the function, it gives it an object and calls it this. Whatever you put in there gets placed in there, and great, now I've got properties on this. And whatever you assign it to is the variable that comes out on the left when you do a new, that's the object. So it turns into this. That's pretty much what you get when you create a constructor function. You just get a function that was whatever the constructor did with the name of the class. You're not Java. You're prototypical JavaScript with functions that like objects. They're pals to objects, but they don't really embrace the whole, we really understand inheritance model. But if we extend one, guess what we're doing? We're adding another prototype. So when you create person off of customer, syntactic sugar-wise, what you're doing is creating a function that will be person, and in it, it will call the customer constructor. So it will add first and last name based on the code in here. Person constructor gets called. And then it calls the setting to orders. This method here goes on the prototype. So the way it works is, because it's on the prototype, when you create an instance of the thing, the prototype is the thing it's created from, therefore the prototype has report orders and everything works. If that makes some to most sense to you, you're in good shape. If it doesn't, spend some time with those things a bit. Okay, so know what it really means when you're creating classes. And everything I just said, if you're using TypeScript, same deal. In fact, even worse. Because TypeScript has this thing called interfaces. They don't exist in the real world at all. They're there for compilation and make sure you type the right variable names. But when you run, there's no such thing as an interface. It doesn't turn into anything. So it's just syntactic sugar to make your life easier and to reason about things. But we're still functions with objects. That's all we are in JavaScript. So I just did a console dir of that. I was playing around with it on my laptop the other day. And so here we have, it's kind of hard to read, so I'll just kind of point these out. So if I did a console.dir of customer, it says, come back and says, well, okay, so there's a prototype on here, and I expanded that out. The prototype has the person constructor on it, which has report orders. I guess the customer's report orders on the prototype and the person constructor in it. And then in that, yeah, it's kind of hard to read. This is kind of reversed of what I wanted to say. So right, there's a constructor for customer, there's report orders on the prototype, then its prototype is person, that's better, and it has say it on it. And by the way, the top level prototype is object. So when you want to do things and they're sitting on object, that's why you can just call methods on object, because the object instance prototype is what everything gets by default. And ultimately, you usually wind up to that. The other thing I want to warn you about is these can be changed at runtime per object. And some frameworks do that to you and make you really mad. When you don't know it, it's really confusing. But when you do understand it, it becomes very powerful. You just kind of live in the way that JavaScript manipulates data, and you're in good shape. And by the way, that is the magic variable for it. In Chrome, for example, I can say thing dot under proto under, and it will show you it. That's the prototype. Oh, by the way, this is a mess, right? Some of this stuff, hopefully, you guys know if you're doing a fair amount of JavaScript. But here's a piece of code with a bug in it. I've got a thing, an object, and I'm going to sneak in a little ECMAScript 2015. I'm using the constant, which is a fancy way of saying I can't replace this variable named customer wrapper with a new variable. It's a constant variable, constant object. Sadly, I can add properties to it, but I can't replace the variable itself. Right? So in JavaScript, it means I can't replace this with a new thing. So it's not immutable, it's just a constant reference. Fun yet? Sorry. So now I've got a property on it called getCustomer. Maybe I'll give it a key. And I'm going to later, 4 or 5 seconds from now, 4 seconds, I'm going to wake up and I'm just going to set this.customer equal to some object. The dot, dot, dot indicates that I'm not done there because I didn't have room. So because I have this set timeout in here, it's going to go to sleep. Now, timeouts and intervals, which are the ways of doing background work in browsers and Node, they don't run on the object they were kicked off on. The window will run them. So guess what this is when they run? Window. Thanks, JavaScript. That was really helpful. But that's what they are. So by default in JavaScript, this will be wherever the thing ran from. And actually, it's not even 100% true, but for many things, this will be the place that the thing ran from. So if it's a timer or something like that, or Ajax, it will probably have the this of window by default. Sometimes certain things don't even have a this, it's undefined. That's even more fun. But there's a way to fix this, literally. So because of the fact that this is window, now I've got window.customer equal to something, and that's wrong. When they created ECMAScript 2015, they wanted to try to give you an ability to fix the problem with the this keyword. And they tacked it onto a new feature called an arrow function. So the arrow function, which is this thing right here, looks like a function without the word function, and it has a little equals greater than sign for the arrow. That's their lambda or their closure, whatever you want to call it. It's their anonymous function. One of the things that it won't do is it won't manipulate the this keyword like the function declaration above it did. So this one here, it will evaluate this based on where that function is running. With the arrow function, it will not change the this from what it was when we called the method that it was on. So when we invoked getCustomer, we probably did customer wrapper.getCustomer, because that's where it is. And because we did that, the this is customer wrapper. So if you invoked customer wrapper.getCustomer, this is customer wrapper when we start running the function. When we do the arrow function as our callback, the timeout picks up the this from the surrounding code, and it doesn't change it when it runs. So it's basically wherever the function was declared, that's what the this is, as opposed to what it's doing when it's running. So that's another useful thing to know and learn over time, is that arrow functions will not evaluate this when they're executed, but when they're declared. So you don't lose the this, and this is now whatever it was, customer wrapper, for example. All right. Promises with async and await. Briefly, a promise is a way, first of all, without the async and await, a promise is a way of asynchronously getting something back later in JavaScript. Who thinks there are threads that you can access in JavaScript? Good answer. I did it quickly just in case someone put their hands up. There are only a couple of types of things you can do. There's workers, service workers, and whatever the heck the other one's called, the one I don't use. But anyway, there are some things you can do asynchronously, kind of. But they have really weird ways of communicating with the page. So let's assume they're not available to us. But in general, if I want to do something asynchronous, and I used an example of navigator.geolocation.watchPosition. Now, this might have changed in the last, I don't know, 5 years since I wrote this sample. It's actually 3. But that API is part of HTML5. In HTML5, if you got a browser that's HTML5 compliant, you have a geolocation API on the navigator object. And you can say, where am I? And I stole this from Don Coleman, our technology director there. And I said, well, hey, how do I get a really precise version? Because actually, what you do is you use watch position. There's like get position, but that's kind of wide ranged. It's kind of like, this is where my router is, so I must be in Philly. But the watch position will give you the most low-level, narrow one we can get. And the first callback is all I care about. Once I get the position, I'm done for this example. So the trick is, and this is what he was doing in some mobile apps, is, hey, go ahead and get me the watch position, and when you get it, call this function for the callback. Now think about the thing that's calling this function. Hey, get location, give me an answer. And it's like, oh, I can't give you an answer. That thing happens later. I can't give you any information. So instead what we do is we say, fine, we'll create a thing called a promise. And there were a whole bunch of promise APIs in the before like 2016, 2017, everyone was using Bluebird and Q and Angular's JS's built-in promise API because there was no standard. But now, part of ECMAScript 2015 is the promise constructor. So they have a promise. And the syntax is a little odd, but it's not terrible. It should create a new promise object, and you give it an arrow function generally, from there to there, and you pass it two variables to the arrow function. It's going to give you these functions. They're functions to call when it resolves with a good answer and functions to call when it fails. And so you just call resolve or reject eventually. So your job is to immediately return the new promise from your function, boom, and then it will start executing the arrow function, and when it gets an answer back, the promise will notify, if you pay attention to it, the promise will notify the caller, oh, I have an answer. So if you don't know about promises, that's another thing. If you're doing anything with Angular or React or Vue or any modern framework, learn promises and learn the ECMAScript 2015 version because that's what you're going to be using generally. By the way, notice here, there is try-catch in JavaScript. You should look into it. If you don't use it and you have an API that throws an exception, that's how you can catch something and reject it, report an error maybe. So now we have two exit paths for this code. Both of them will eventually, one of them will happen, or the other one, in theory. Now, how do I, from the calling piece of code, get an answer? I call then. Right? Now, this has been around since forever. Bluebird and all the other ones have this exact same signature. And it's promise returned dot then. They call promises thenables. When I get an answer, and there's two options for the answer. One option is I got a successful answer or resolve. So in the first one I say, oh, great. Well, if I had an error condition, I'm going to clear it just to make sure I don't show an error. And by the way, my coordinates are whatever payload off the location that I returned are. And there's one for the error situation. So if it fails, then I want to report an error. But there's a different way to do that. In ECMAScript, I don't remember exactly which one, 2016 and 2017, they added async and await to the language. I think it's 2017. But you'll notice that there's this little keyword here in front of the function call, async. And this is part of the language, and this says there is going to be something that will happen later in this code, but I want to treat it like it's imperative code when I look at it. It's syntactic sugar. Behind the scenes, you have a then, and it's being resolved. But for you to read it, at least until you get the binary version of this, whoops, at least until we're not transpiling it. But async, get location, and by the way, this goofy thing is it's a property that is an arrow function. Variable, it is an arrow function. And in classes, they're called arrow methods. That's the technical term. Long story. But this is a pretty common syntax you'll see in a lot of the code. The main thing I'm teaching here is the async and await. So when you say async, you're allowed to use the await keyword wherever there would be a promise. And it will logically resolve the promise before moving to the next line. So, for example, in this other version, if I have get location then, and then I've got code below it, it's going to fall right through that after it registers the two functions and eventually call the success or error. So if I had a whole bunch of code that expected to happen after this was all done, there are ways to do it, usually in the then or in another then, but they're complicated. In here, I can treat it almost like it's imperative code, almost like it's imperative code. I have to realize it's still running a promise behind the scenes, that things could fail. So for example, that's not a particularly clean example, because what if it threw an exception? So with async await, you can put a regular try catch on. Because if await fails, it throws an error. And now I can pick the error up and I can deal with it. All right, so same thing, async wait, but just put a try catch around it. If the await fails, we blow up. So that's generally the async and await feature, another important thing. All right, we're almost done with this. So real quick, is anyone here comfortable with stuff like this? Map and reduce and stuff, chaining them? Good. So what it is just we're doing functional programming. We're taking a collection, transforming it, then calling another thing to transform it again. So map, we're saying, square the numbers. And that returns a new object. By the way, I should have had a let answer equals here, because it's not doing it in place. It's returning a new one. So I could say items.map.reduce and return that back, and it would be 55, because it would square them and then add the squares together. I'm mentioning that only because of the next topic, and that's observables. So actually, I didn't plan on doing this in Vue, but I ended up with observables in one spot. I ended up using observables for the chat system that we have. And the rest of the teams all used RxJS observables. And the reason we did is because it's an API that's really good for streams of events and streams of data. Really good for that kind of thing. There's stuff you can do in RxJS that's very hard to do in other places, just because it's really nice to compose these kind of streams of events together. So it's an ECMAScript feature candidate in that they've been trying to get observables in the language. Before they created ECMAScript 2015, they called it ES6, right? And then they had an ES7, like what happens when we get past 6? It'll be 7, right? And in 7, like we're gonna do observables in 7, they dropped that. I don't know when it's coming. Neither did Microsoft at the time. They said, well, we're making a reactive standard, Rx standard. So there's Rx Java, Rx Python, Rx whatever. Let's do an RxJS. And then they donated it as an open source library. So it's a very popular library out there that does streams data as the observer pattern. You're basically saying, I'm going to subscribe and watch for changes in this stream of data. And or generate a stream of data. So RxJS is the library that all three of our teams are using in different parts of our applications. Think of it like a promise that might never end. Sounds familiar? I have 4 kids. I have lots of fake promises I hear all the time. I'll clean my room. Keep telling me. So it's like a promise, but there's actually the ability for it to run as long as you want it to run. I can subscribe to something and listen to it until I shut down my browser or until I navigate to another component, that kind of thing. And basically, and I did a real simple one here as an example, let's take that collection concept. Let's take a collection of numbers. RxJS, I forgot that's a typo. Import from RxJS. RxJS is a library. From is a creator of an observable stream. In this example, we're going to create a stream of 5 entries. It's just going to walk through the whole array and say, emit, 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 emit. 1, 2, 3, 4, 5. So that would just output 5 different outputs. And I could do that from like a predictable finite stream of information. And that will be an observable that eventually closes. I can also do it from a mouse event. So there's something called from event. I stole that from you guys. Thank you. At least from the reference you had. So mouse move, I could say, grab the mouse move on document, and as I'm moving along, calculate the squares of pi and lock up my browser. Oh, that's not the right one. Slow it down. But the bottom line is I could say, give me mouse move, and I can subscribe to that, and I can report where the mouse is. I can also say in the middle of that stream, you know what? I only want to update every half second. So give me only this often, give me the output, right? Or maybe only when it changes, or maybe I want to transform it into some other dimensions. Something like that. A distance kind of thing from the last one. So those are just 2 simple things we can do with observables. To learn them, concept-wise, there's this nice little website called RX Marbles. Go to that. I did that in the wrong browser. Now I'm really hopefully, so much unfun right now. Yeah, let me just show you this, and then I think we're running up to time. So that is an example of some images, and Matt Gilbride has looked up and found a nice utility in Python to do this. So you can build your own diagrams, which we think is pretty cool. But it's for every single type of operation you could do in RxJS. Now, it's a little out of date, But concept-wise, it'll teach you what to do. So the idea is if time goes across, each of the different colored circles represents a particular emitted thing. So merge says, I'm going to take these two streams up top and output them as one observable. That's one. We could do, for example, combine latest. That's another cool one. Every time one of them emits, take the last value of both and give that out. So you can say, give me the latest from these 5 different streams of data, and every time I'll have the up-to-date snapshot of whatever it was at that time. There's really great stuff in here. Just adding a delay for a demo that they were doing, or doing like taking only so often, or getting rid of duplicates is simple, very simple. In fact, there's even an Ajax API for that. You guys are using that, right? Yeah. So you have like an observable called Ajax. You go get something, and it brings it back as an observable. The reason I mention that is because Angular, as Rich is going to talk about, loves observables all the way through the system. And ultimately, it's a nice API to work with. All right. And this is just the, this screen I'm looking at that's not yours. That one. This is a bad graphic. I promised to update it, but I did not. But what we're seeing here is a growth of single-page apps according to, I believe this is Stack Overflow questions. So you can see that the big giant volcano of doom is AngularJS. You can see it's kind of like, yeah, we've all done that, we're moving on. Mostly because the Angular team finally announced that they're going to sunset it in a year or two. So everyone's like, now we got to do something different. So we're stuck. So it's kind of a forced obsolescence by Google. Thanks, Google. And then Angular rose to meet a challenge because now people are switching to Angular in the enterprise from AngularJS, which is the old one. On its heels, React also got very popular because while the Angular team was getting their act together and trying to get everything working for 2 years, React was out there and working. So a lot of people adopted React and said, well, this works. And it's a different approach. It's a more put things together yourself approach. So some developers like that. And it's interesting to see that both together are far more than what AngularJS was when it was popular in terms of questions. So we basically doubled the market of questions, at least, according to that. And Vue is starting to climb up there a little bit. I suspect that'll be more and more over the next year or two. They've got some hurdles to catch up with. All right, so the rest of the day, what are we going to do? Pete Fleming is up first. He's going to talk about user experience design. So how do you deal with like making a good user interface that people want to use? Rich Friedman is coming up after him to talk about Angular. James Kent and Matt Gilbride are going to talk about React. I think we're going to have lunch sometime around there. Lunch is on us. And then we have me talking about Vue. After that, Jeff Lebonsky is going to do 2 talks, and I'm going to sneak in between them. Because darn it, I don't like someone to have 2 talks in a row. So yeah, he's going to do one on NodeJS and some of the server engines that are out there. I believe that's the first talk. It's going to talk about Happy, which is an interesting API for doing server-side JavaScript. I'm going to sneak in and talk a little bit about Spring Boot. We have the same backend written both in Spring Boot and written in Happy JavaScript server stuff, Node. So you can take a look at both of those when we give you the repo. So I'm going to give you the 15 minutes on here's how Spring Boot acts as a nice happy wrong term, a nice web server for single-page apps. And then Jeff comes back again to talk about continuous integration. At the end, around 4:15, I believe, we'll put the chairs up and we'll have a long panel discussion until people throw us out of here. So we'll have about 15, 20, 40, whatever minutes, whatever's left at the end, for you guys to ask us questions as well and to kind of debate some topics. All right, so that's what we're going to do. All right. And am I running into your talk already, or are we just at your talk? Good. All right. So we're going to switch now, and we're going to get started with Pete.